We are back once again. The days are blurring together. The silence is deafening within my head. There are voices, and I need to stop. This is day 142. We are back once again for some weekly suffering. We still haven't done the weekly contest. We still aren't waking up early. But there is one thing that we are doing, and that is the LeetCode problem. So we're on to something there. We need to figure out what's going on and continue doing more so that we don't stop. But yeah, I was doing some thinking. I do LeetCode, daily LeetCode, but also I've been doing some game dev on the side, and I think this is the wave. So yeah, I've been doing some game dev. I think it could be pretty cool. I'd be interested to see if this project could go anywhere, but we shall see. Maybe I'll have more information soon. My last project, the Discord bot, was not received well. So we shall see what will happen. Also, yeah, it's just more LeetCode to be done. Just more LeetCode to be done. And it's interesting to think about because at this point, for some reason, day 0 to day 30, or day 60 or day 70 felt like an eternity. 70 to a day almost 140 now. It feels like it's on fast forward. So I guess that's just how it works. So it feels like it's on fast forward. So we shall see what happens. But yeah, the days kind of blend together. So LeetCode as a vehicle for training focus may be the wave. I used to read, I think like around day 100, pretty much day 120, I stopped doing a lot of things. So I was constantly reading the ADM. Now I'm not so certain that's the wave. I think that could be the wave actually. Reading the ADM regularly is probably a good thing to do. But I was also reading about system design constantly. And then I was doing an hour of back end and an hour of front end. It was actually pretty crazy now that I look back on it. It was a lot of stuff being done there, but at the end of the day, I realized I wasn't really making anything. So, yeah, what's the point of learning all those things if I'm not going to make anything? So, it turns out it was easier to learn those things than it actually was to spin my wheels on something that's difficult. And it's just always interesting to see that it's always harder to create than it is to like just do something else that's really easy. Like I forgot someone said this, but I don't remember. But it's like if you plan to work out, it's easier to spend tens of hours looking up the best treadmill, the best running route, the best running app than it is to just get out there and start running. So I was pretty much doing the same, except with tech. Ultimately, the point of all these learning and stuff like that. I mean, also it's also the sake of learning for the sake of learning, but also it's important to make stuff. But yeah, I was just learning infinitely, and then it became questionable why I was learning. I did the same thing with Anki, which was a spaced repetition app. You just use the cards and you learn a bunch of things. But at the end of the day, I mean, these are just tools. So why is one learning? That is an important question to ask. So I pretty much threw everything out in the trash. I said, what do I want to make? And it turned out to be that it was a game. So that is what I'm going to do. That's what I have been doing. So that's what I'm working on. But yeah, I think it's just better to just actually make something. Also, the position where I work, I've been solving a lot of problems recently. And it's just interesting that you don't necessarily always have to understand everything. You just kind of have to be able to solve problems. So that's kind of a breakthrough in another way. Solving problems is the cheat code. So that being said, many things are on the way. And hey, the next project could be pretty cool. So we'll see how far I get. But one thing we won't have to see how far we get on is LeetCode, because we make consistent progress every single day on this godforsaken website. I don't even remember the problems we've been doing. It feels like every day I work on an easy problem, they add 5 more. So I actually can't tell if we're making. Actually, we are. I think last week we're at 170. Now we're at 173. But I think they add probably like, I don't even know anymore. I actually don't even know. Let me see if I can find out. See if I can find out how many problems they added recently. Because at this point, LeetCode is wildin'. I don't understand. So let me see. Yeah, I'd be curious to know how often does LeetCode add problems. LeetCode add problems, because if they're adding faster, if they're adding like a crazy number of problems every day, then yeah, if they're adding like a crazy number of problems every day, how are we going to make progress? So it's actually really hard to know. I can't find any solid numbers. I should look back on my other videos when I've clicked my profile and see how much has changed, because I actually can't tell if they've added like another 60 problems while I wasn't paying attention. So yeah, maybe, yeah, I still wanted to do all the easy problems first. So at this point, we've seen quite a few problems, but clearly not enough. It'd be interesting to see in the future how it's just interesting, because now I'm seeing, I can definitely tell some patterns in a lot of these strings and fundamental or foundational string and array problems. But the people who've done all 1,300 mediums and all 500 hards, I mean, this must be remedial. They've seen everything under the sun. So that's pretty cool. It'd be cool to get there. So yeah, that being said, progress must be made and evil must be thwarted. So that is the goal, as always, with daily LeetCode. The plan is always to learn. So I think we've done 30 minutes pretty frequently recently. Let's do a necessary evil. Let's do something in between at 45. I can't believe we used to do an hour every day. It's just crazy. So let's do 45. Let's jump into it. So we have richest customer. You are given an m by n integer grid accounts, where accounts sub I sub j is the amount of money the ith customer has in the jth bank. So we have I customers and j banks. Return the wealth that the richest customer has. Is this just taking the largest of the rows, taking the sum, keeping the largest sum of all the rows? So we'd have 1, 2, 3, 1, 2, and 3, 2, 1. We have two customers. Count sub I sub j is the amount of money the ith customer has in the jth bank. So I is the customer and j is the bank. Pretty much like a table. We have to return the wealth that the richest customer has. The wealth that the richest customer has looks like it would be the sum. Oh yeah, it would be. Would be 6, because they both have a sum of I was like 3 plus 2 plus 1 equals 5. It equals 6. So right, the answer is 6. In this case, the answer should be 10. The answer is 10. In this case, we have 287 287 713 287 713 287 2817. Then we'd have 11, and then we'd have 15. I wanted to visualize this matrix in my head, but I couldn't do it. Very difficult. It looks like we're just taking the sum of the largest row, or keeping the max of the. We have I rows. We want to return the I. Pretty much want to return the row with the highest sum, or return the maximum sum of all the rows, or return the row with the maximum sum. So let max sum equals 0. And then we'll pretty much just do let I equals 0, I is less than. Actually, let's check the constraints to make sure we don't miss anything. So accounts.length, n equals accounts I.length. Looks like we're given a potential square or rectangle. We have at max, we're given at least one row and one column, which is good. The accounts of I sub j, the value is bounded between 1 to 100. So we can just say accounts.length, I plus plus. We'll move this forward and we'll use R and C just because it's a little easier to follow that way. Actually, I'll move my chair up. And we'll have R here. Actually, is this even showing? Oh my God. Wait, why isn't this showing? I see. Rip. That was unfortunate. So now we pretty much have it set up. And then we're going to swap I for C. We have to return a number. We'll return max sum at the end. We're going to need a cur sum, which is going to start at 0. Pretty much going to do cur sum plus equal accounts of R sub C. And then at the end, we'll say max sum is equal to the math.max of max sum or cur sum. I went a little too fast. We'll take it. There should be linear time or m by n operations with constant space. So we're given this has a lot of downvotes, so this is going to be a doozy. Let's try find n unique numbers, sum up to 0. Given an integer n, return, let me see if this is the recording. Given an integer n, return any array, okay, so we're given a number like 14. Return any array containing n unique integers such that they add up to 0. So we're given an integer like 14, and we want to return any array containing 14 numbers that add up to 0. So if we're given one number that adds up to 0 would be 0. It seems like this should always be possible. Or maybe, well, no, it should always be possible. Can we use floating point numbers? I don't see why not. Well, actually, probably be hard to actually, since floating point numbers don't actually round up to the zeroed numbers correctly or integers correctly. Let's just say we're going to use all integers to sum up to a value. So let's just say they gave us the integer 3. So we come with 3 numbers that they sum up to 0. You could do 0, 1, -1. That's what they get, right? Then we could do, what if we did 4? We could do 0, 1, -1. So that doesn't quite work. You could do 1, 3, and then 4. Or, I mean, -4. Now, if we did 5, we could do 0, 1, 2, 3, 4. 1, 2, 3, 4. And this would actually give us 4 plus 3 gives us 7 plus 2, give you 9 plus 1 will give you 10. So we'd have to do -10. To count up. So I think this could work. So we'd have 1 for, let's just say, let's change our strategy for 3 here. Let's just say we have 1, 2, oh, so we, looks like 0 could work. So we can do 0, 1, 2, and then we do -3. Well, actually, that would be wrong. So I think this could be done because we could pretty much choose a number at the end based on Gauss's formula, or just based on the sum of the numbers going up. So I think I'm just curious if you could subtract 0 from it. Do 1, 2, 3, and 4. Right, then add 5. We should get 15. Now, if we do Gauss's formula, I think it's n times n plus 1 over 2. So we do 5 times 5 plus n times n plus 1 over 2, and you'd get 15, and we just have to make that number negative. So I think you actually can skip 0. You could do 1, 2, and then -3. You could do 1, 2, 3, and then the negative of the sum of the numbers up until that point. And then if you have a special case, right, if n equals 1, we can just return an array with 0 in it. It looks like n goes to 1,000, so it looks like this could work. It looks like we just have to iterate up to and including n, or actually before n, and then add the negative of the sum as the final number. So we can say const, let me just visualize it. We're just going to iterate up to n, and we'll keep the sum. At each iteration, we're going to add I to the array, and we'll keep the sum. And then the final thing we add into the end of the array is just the negative of the sum. So we can say ands is equal to an array. We'll return ands at the end. We're going to say for let I is equal to 0, I is less than n, I plus plus, ands dot push I. For some reason, I think implicitly this, there we go. Then we'll have a sum which is equal to 0, and we'll do ands.push the negative of sum at the end. And then we'll always do sum plus equal, and also do sum plus equal I, and I is always going to start at 1. It looks like this would be linear time, potentially constant space. Potentially constant space, because our space could be included as our output space, but it's unknown. And yeah, I guess linear time, where n is n. So we do that many operations. I don't think there's... So we'll close this one. We have number of days between two dates. I feel like this is probably an issue just because I've done a similar problem before and it can be quite annoying. Write a program to count the number of days between two dates. Number of days between two dates. The dates are given as strings. Their format is YYY, MMDD as shown in the examples. Just returning the number of days between two dates. This is pretty difficult, but I feel like it depends on the language here, because handling dates is pretty difficult. But I think we could get, what if we did something like the milliseconds, or a day in milliseconds, which would be 1,000 milliseconds, 1,000 milliseconds. If we got the day, if we could figure out the number, how many milliseconds a day is stored in, we could use the epoch time to figure out. No. We could just divide it by day in MS to figure out how much time has passed. Since we're not given a time, though, it'd be interesting what we have to assume. So 1,000 milliseconds times 60 seconds. 1,000 milliseconds is a second. There's 60 seconds in a minute, and then there are 60 minutes in an hour, and 24 hours in a day. Now we could say date 1 ms is equal to new date 1 time value in milliseconds. Say date 2 could return the difference between the days This seems pretty ghetto, I'm not gonna lie. Oh, I'm genuinely surprised that that worked, but we'll take it. Interesting. Why does that work? I don't know. Maybe we're not allowed to use API. I'm not certain, but I don't think this is super important. Even if when I would write my own date programs, I would just not use handwritten date logic. Remove all adjacent duplicates in string. You are given a string S. You're given a string S consisting of lowercase English letters, abaca. So you have a string, lowercase English letters. A duplicate removal consists of choosing two adjacent and equal letters and removing them. We repeatedly make duplicate removals on S until we no longer can. Return the final string after all such duplicate removals have been made, and it can be proven that the answer is unique. So for the answer abaca, is the answer C? It seems like you can just look between your adjacent locations and then remove strings based on that. But who knows? Most importantly, we need an algorithm that when it replaces the current strings, it doesn't go to the next one, because that removal of that duplicate could create another set of duplicates for which we check. So what I mean by that is if we have something like A, B, B, A, C, if we remove B, B, the algorithm likely would keep going. We don't want that. We'd like it to stay exactly where it was. Looks like this could be a two-pointer problem. If we remove B and B, right, we have A, B, they're not the same. Then we move to the next one, we have B, B. So we set both of these as some variable, right? We nil them, which means to get actual values again, we'd have to either go forward once and backward once, for which we can continue Actually would be simplest with a linked list. I feel like a linked list is overkill. I feel like there's definitely a 2-pointer solution here. Use 2 pointers. You can have one at X and one at the next X. Problem is, if you turn it into an array, when we remove something, the current positions break. But if we were to remove those specific positions, you could just remove those 2 characters. Indexes 1 and 2 would become indexes 0 and 1. So we could just subtract and then keep going. So I think as long as we turn it into an array, we make sure to remove the spots in the array. Actually, no. We can do the same thing if we just mark them as processed already, and when we increment them forward once, we'll just make sure that it skips, that it always skips in front of it. For example, if we have abaca, we'll just turn these into spaces, right? But now, turn these into spaces, but now what did I just say? Linked list version would be dead. 2-pointer version, there could be 2 ways to do this though. The first way would be moving duplicates, remove duplicates, whereas the other version would be replace duplicates. Now, replacing duplicates is actually starting to sound a little bit cumbersome. So what if we just remove the duplicates? So we turn this into this. Then it looks like we could just backtrack the indexes. Or we just backtrack one index, the next index is always dependent on where the current index is. Then we could remove both of these. My problem is, if we have something like this, how do we know when we do BB How do we know when we remove BB, we should go back and do AA, right? Because if we have AA at the front, it ends up coming to light. We can just do this, but you end up with ACA, which is because the answer would just be different. I think there's also another case where you get something like this, where if you remove BB and you remove this one, you remove AA, BB. I'm thinking now this doesn't actually have to be an iteration. We just live at the front. AB isn't a duplicate, so we do BB. Go back to the front. A is a duplicate. So we could do while there's a duplicate. Could just do I feel like you could just do brute force it, do n squared operations, and just do check every index, check if there's a duplicate next to it. If there is, you remove it, then you keep going. Issue with that being for loops wouldn't really work well to a list that's moving up and down or whose size is growing and shrinking. You could do the same thing with the two-pointer approach, except the next index you find is pretty much just the next index. That's not a non-space character. Because if we turn it into an array, that would be n cubed. So let's try that. Pretty much just going to write two while loops and just have it go through. Check the current index and next. If there's a duplicate, then we'll just return it. Then we'll just remove it. So we'll spread the string passed into this function into an array for which we'll say that inner equals, or I have an inner and an outer. We'll say while outer is less than r dot length minus 1, we'll do the same there, and inner is going to be declared in here. Inner is going to be equal to outer and then from here we're just going to say if r sub inner equals r sub inner plus 1, but basically only if r sub inner exists and r sub inner plus 1 exists. Now if that's all true, we can do inner you can say r is now going to be equal to the array of r dot slice going from 0 exclusive of the end. So we can say go all the way up to inner, right, dot concatenate to r dot slice inner plus 1. It'd actually be inner plus 2. Going to the end. Interesting. Yeah, this is what I thought. I think the version that we need to do instead, I'm pretty sure this current version is n squared. It's also unclear how long it takes since we always go back to the start. I think we need a more systematic method that's not literally making our runtime unbounded. I think we can do the other version instead. There'll be two cases. If we remove BB here, we can check if a previous character exists. If it does, we'll go back and we find our next index, it'll be A here. In the other case, right, if we remove BB, we set it equal to space, right? Let's just say it's something like A. If we ignore the BB here, say something like AA. If there's nothing behind us, then we just move forward until we find the next index, the next non-space index. That should take less time. So here we can do something like P1 and P2. If it exists, if there's a character behind us, then we'll go get it. If not, we'll look forward until there isn't another character. So in that case, I have P1 equals 0, and then P2, which is equal to 1. And we'll say while P1 is less than s dot length. Now here we need to check, right? If r sub P1 minus 1, right? If it actually exists, and r sub P1 minus 1 does not equal a space character, then we pretty much want to say P1 equals P1 minus 1, because it means we have a character behind us that we can use. Otherwise, we want to literally look forward until, so say y r sub P1 equals a space character. We're going to say P1 plus equal 1. We'll duplicate this. Oh, and then we actually don't need P2. P2 will actually be determined. We'll say P2 equals P1 plus 1. We'll say while r sub P2 equals a space character, P2 plus equal 1. Right now, if r sub P1 equals r sub P2, then we want to set r sub P1 equal to a space character. We can duplicate this and do the same thing for r sub P2. What we're actually going to want to use is an empty character instead. So when we join them, I think I forgot to increment P1 regularly. So if we test this on A, BB8, P1 is equal to 0, right? P1 minus 1 does not exist. So while it's empty, we're going to look forward, but we're good. P2 equals P1 plus 1. Doesn't equal space. They aren't the same. I think we might want an else here. The else being that if they are the same, we just set them equal to empty characters, which will be handled on the next iteration. But if they aren't, we can just do P1 plus equal 1. Not understanding. So they aren't the same. We do P1 plus equal 1. P1 plus equals 1. Now it equals B. Oh, and the other reason we want to go back is if our current R sub P1 equals an empty space character. Interesting. So with this version, we do XX, we go back, we get ZZ, but I don't feel like this maybe I need more brain sauce. So I think we're just going to end there for today. My brain is kind of fried.